Increasingly, the Big Bang's predictions are being contradicted by better and better data. The scientific community is buzzing over some recent mind-boggling discoveries by the James Webb Space Telescope. From behemoth black holes that seem to defy our cosmic timescales to puzzling galaxies and stars, James Webb has given scientists many proofs that completely shatter the Big Bang theory. Many experts are now seeking a complete overhaul of our current cosmological model, and some have even developed a new model to explain the recent mysteries uncovered by James Webb. What are these recent mysteries uncovered by James Webb, and why are they so upsetting? What new theories and models have been developed to explain these mysteries? Where does all this leave our current model of cosmology and the Big Bang theory? Join us in this video as the James Webb Telescope finds the first real evidence that shatters our cosmology. After the Big Bang explosion, everything began to spread and expand, with a corresponding decrease in temperature and pressure. In other words, things began to spread and cool down. After about 300,000 years of cooling, the first generation of atoms was born. In the next few million years, cosmic gases like hydrogen and helium emerged. Scientists called this era the Dark Ages. There were no stars at this point. It took hundreds of millions of years before the first stars were born. These first stars were formed from small pockets of gases with higher densities than usual. The high density, coupled with the stronger gravitational pull that they experienced, helped them reach a critical threshold that ignited nuclear fusion, birthing stars in the process. Now you know how stars were formed. You may be wondering, what about galaxies? Well, after the first stars awakened, gravity brought together small gas clouds and stars, allowing them to merge into larger and larger structures over time. As millions and billions of years passed, star clusters became galaxies, and galaxies formed clusters of their own, until eventually, the superclusters we see in the cosmos today were born. The exact method or processes galaxies underwent in their formation remain a mystery, and scientists are still investigating to know all about it. However, this doesn't in any way falsify the Big Bang theory. There's one component of the cosmos that serves as strong evidence that the Big Bang actually happened, the residue of light from the Big Bang called the cosmic microwave background, or CMB. The CMB is a faint glow that surrounds the entire universe. It's one piece of evidence supporting the Big Bang theory. Although several pieces of our cosmos have always seemed to support the Big Bang theory, there are still several loopholes that scientists and cosmologists have been trying to fill. Truthfully, most of what the scientific community knows about the universe's origin is based on theories and assumptions. Some experts have always wished we could find a way to travel back in time to see how things were during the dawn of the universe. Well, that wish was partially granted with the launch of the James Webb Space Telescope. James Webb has given us more hidden details of our universe than any scientific instrument before it. With James Webb, scientists can now peek into the deepest parts of the cosmos to see some of the earliest formed stars and galaxies, thereby verifying whether our theories are true. Every time scientists peek into a different part of the cosmos, they discover something that was never before seen or imagined. For instance, James Webb, which is stationed about 1.5 million kilometers away from Earth, was designed to observe the universe through an infrared lens like no other. Initially, scientists thought it might take a while for the JWST to discover the oldest galaxies in the universe. This is because most experts had theorized that these early galaxies would be quite small, underdeveloped, and probably unorganized. But James Webb's images of the early galaxies were actually the opposite. Instead of tiny premature galaxies, scientists were shocked to find huge, mature clusters in the JWST images. This discovery raised several questions in the scientific community as experts began to probe the Big Bang theory, how such perfect galaxies could form at such an early stage of the universe is beyond comprehension. But you see, this was only the beginning. The JWST kept sending back more mind-blowing pictures of the cosmos, some of which seemed too good to be true. In fact, so far, you can say that JWST has raised more questions than answers about the cosmos and our cosmological model. Could there be an error in James Webb's calculations and observations, or is our universe far more complex than our present theories and models can explain? Scientist Mark Macaron, one of the senior scientists at the European Space Agency, said about the James Webb Telescope, "You build these machines not to confirm the paradigm, but to break it. You just don't know how it will break." In essence, James Webb has broken some beliefs and notions about how our universe formed. One such belief is that galaxies formed slowly over the course of millions of years. You see, it is believed that long after the Big Bang, when the universe had cooled, gravity had to first pull together denser regions in the cosmos to form stars and black holes. This process continued until galaxies and galaxy clusters were formed. However, data from JWST revealed that some massive galaxies formed quite quickly after the Big Bang. Some of the galaxies JWST spotted were just as mature as the Milky Way galaxy. In fact, initially, scientists found some of them so disturbing that they renamed them universe breakers. One strange, intriguing galaxy that was revealed by the James Webb Space Telescope was the galaxy BR 133350417. This spiral galaxy was discovered to be 12.4 billion years old, merely a billion years after the Big Bang. Such a scenario doesn't really conform to our cosmological model because the first galaxies were thought to have formed around a few billion years after the Big Bang. Physicist Garo Barrow from the University of the Pacific said about some of JWST's astonishing galaxy discoveries, "We have discovered mammoths in the universe at a time when it seemed like they shouldn't exist. Now we need more data to discover how they got there." But the strange galaxies weren't the only things that seemed to defy our cosmological intelligence. Scientists also discovered the oldest black hole, which is 12.8 billion years old. Considering that the age of the universe has been agreed to be 13.7 billion years, the black hole seems too old. There's a great controversy as to how a fully developed black hole came into existence barely 900 million years after the Big Bang. Although 900 million years sounds unfathomably long, it's merely a few hours in cosmic timescales. But the big question is, how could a black hole form at a time when matter was supposed to be in its infancy? Scientists have agreed that the time frame for the formation of one research paper published by scholars at the University of Michigan suggested that the inconsistency in the structure of the universe may be due to some additional force besides gravity and dark energy. This unknown force would also be partially responsible for causing dark energy to continually stretch out or expand the universe. A few scientists find this theory worth pursuing, but several others need convincing. Surely, if another force were at play in the universe, we probably would have witnessed it or seen its effects by now. So it's either this paper is wrong in this regard, or more research is needed to justify its claims. The scientific community is still very open to new ideas and theories, but then again, such theories won't see the light of day without sufficient proof. The current model of cosmology took decades of hard work, dedication, and collaborative efforts from hundreds of astronomers and physicists, including Albert Einstein and Edwin Hubble. Thus, even if there needs to be a departure from this standard model, such a feat would be impossible unless a plausible new model comes from reliable and reputable members of the scientific community. Such new models or theories must also have strong allies or evidence to back them up. Scientists have gone beyond using instruments like the James Webb alone. They're also deploying the help of supercomputers and AI to crack this universal puzzle. Some researchers at NASA have constructed a model for galaxy formation in the early universe and subjected it to simulations on a supercomputer. Hopefully, in doing so, the scientific community will finally understand why so many details of the universe do not conform to what we thought we knew. Although the research is still in its infancy stage, the researchers have already come up with a possible explanation for our current cosmic predicament. They proposed that stars in the early dawn of the universe may have undergone sudden intense bursts of formation followed by short periods of inactivity. In other words, the first stars in galaxies may have formed quickly, perhaps as quickly as a supernova explosion. Note that this assumption deviates from what we know about star formation. Usually, the birth of a star is a slow, steady process that takes at least 1 million years to complete. Given that we're dealing with the dawn of the universe when everything was pretty much irregular and premature, stars may have taken much longer to form. This new proposal of stars that formed almost instantaneously is unconventional for the scientific community. However, it would be a good explanation of how the early galaxies formed so quickly and why these galaxies are so mature. One other thing that was detected in the mind-boggling galaxies that the JWST detected was that they were unbearably bright. Usually, distant galaxies appear as faint glows on the JWST space imagery. Sometimes, finding such galaxies is not even possible except with gravitational lenses, but these galaxies were bright beyond imagining. The team of scientists that spearheaded this research with a supercomputer suggested that the abnormal brightness of these galaxies is due to the sudden way their star formed. In other words, there was a sudden let-there-be-light moment in the early universe, and the stars that formed at that moment are nothing like the stars that form in the cosmos today. Their theory also suggests that galaxies didn't form using the normal process scientists see today. This means that the galaxies didn't start off small and later grow into massive clusters through mergers and long-term grouping from gravitational forces, as we have predicted. Instead, if this star formation happened as sudden bursts, galaxies were probably formed in similar ways too. A lot of lines still need to be connected to make this or any of the other models that are springing up a perfect substitute for our standard cosmological model. Also, there's still no assurance that any one theory can adequately answer the puzzles of the universe or fit in its many variables and constants. But the scientific community isn't relenting in its efforts to get to the root of the matter. Whether it's about rewriting the entire cosmological model or making adjustments to Einstein's theory of relativity, there's no doubt that our experts will find a way to crack the universal puzzle. With multiple experts working hand in hand and phenomenal gadgets like James Webb still operational, more data will surface for experiments and analysis. But until proven otherwise, the Big Bang Theory remains our best explanation of how the universe began. While you're still here, make sure to click the video on your screen for more mind-blowing episodes about space.